Right now, in 2026, there's this YouTube channel that is just raking in brand deals, Amazon affiliate commissions, subscription revenue, all of it. And the host is super charismatic. Her aesthetic is, perfectly dialed in, and her pacing keeps audience retention well above 70%.
Yeah.
But here is the catch. She is completely fake.
Right. Entirely synthetic.
Yeah, totally fake. The person actually running this whole media empire has never once turned on a camera. I mean, their entire staff consists of about 10 pieces of code quietly talking to each other on a local server. So, welcome to the deep dive.
It's really the ultimate execution of a concept we have been tracking for years, but I feel like it has finally crossed that threshold into absolute viability. Like, we are officially moving from an era where AI was a tool you use to an era where AI is, well, it's the staff you manage.
Exactly. And that is the core premise we are unpacking for you today.
Yeah.
We have a massive stack of cutting-edge research to synthesize. We're looking at the brand new 2026 AI Index report from Stanford HAI, some really deep architectural analyses from IBM and Microsoft, plus, the latest CES 2026 coverage from Wired and MIT Technology Review, and technical teardowns from ByteByteCo.
It's a lot of material.
It is a ton. But we aren't just going to read you white papers. We are grounding all of these macroeconomic and technological trends in a real-world case study for you. We're going to dissect that exact faceless media brand I just mentioned, which goes by the name The Baddie Blueprint.
And what makes this stack of sources so fascinating is really the convergence. You have these massive global enterprises and, solo bedroom creators arriving at the exact same operational conclusion simultaneously.
It's wild.
Yeah. The goal of our analysis today is to extract the exact systems, like the actual agentic workflows, that are turning solo operators into entirely autonomous media companies. And then zooming out to see how the underlying architecture powering them is rewriting global economics.
Okay, so let's unpack this, because the mental model really has to shift first. If you are listening to this, you need to completely discard the idea of being a content creator or like an operational manager in the traditional sense. The best analogy I can offer is that you need to start operating like Rick Rubin.
Oh, the music producer.
Yeah.
That is a highly precise way to frame the new dynamic, actually.
Right. Think about Rick Rubin. He doesn't play the drums. He doesn't play the bass. Famously, he doesn't even really know how to operate a mixing board.
He just lies on a couch.
Exactly. He sits on a couch, he listens, he defines the creative boundary, and he directs a symphony of incredibly talented musicians to execute the vision. And that is what you are doing in 2026. You are the conductor. You're sitting at the soundboard directing a symphony of AI agents. You are providing the taste, the brand guidelines, and the final editorial approval. But the agents are doing the playing.
But to understand how we actually arrived at this Rick Rubin phase of management, we have to look at the architectural leap that separates the AI of 2024 from the AI of 2026. Because a lot of people are honestly still operating on the 2024 paradigm.
Oh, totally.
They are stuck in what IBM's Chris Hay refers to as the era of the single-purpose agent.
Right, the era of just prompting.
Precisely. If we look at the MIT Technology Review and IBM trend reports, they make a really stark distinction. 2 years ago, interacting with AI meant opening a browser tab, typing a prompt into a chat interface, and, waiting for an output. It was a single-turn interaction.
Yeah, the AI was basically an intern who could only execute the immediate task in front of them.
Right, it had zero situational awareness, and the second you closed the tab, it forgot you even existed.
Right, and if you wanted to do something complex, say you wanted to write an SEO-optimized blog post based on a 40-page PDF.
Yeah.
You had to manually chunk the PDF, feed it in, ask for an outline, copy-paste the outline into a new prompt, ask for a draft, copy-paste that draft into another tool to check the SEO.
Yeah.
I mean, you were the manual routing layer.
Exactly. You're doing all the heavy lifting to connect the disparate capabilities of the model.
It was exhausting.
And that manual routing is exactly what has been automated away by what the industry is now calling super agents. We are transitioning from isolated prompting to actual workflow orchestration. Brian Raymond, who is the CEO of Unstructured, he provides a brilliant breakdown of how this is happening at the data ingestion level through something he calls agentic parsing.
Okay, yes. This is one of the most vital technical shifts for anyone dealing with massive amounts of data. Raymond's white paper highlights a profound flaw in how we used to process information.
Yeah, the monolithic approach.
Right. Previously, if an enterprise or a researcher had a monolithic 500-page document, right, like a mix of text, financial tables, and complex diagrams, they would just shove the whole thing into an LLM's massive context window and, hope the attention mechanism could figure it out.
Which almost inevitably resulted in high latency and severe hallucination rates. Because, I mean, think about it. You're asking a generalist model to simultaneously act as a linguist, a data scientist, and a computer vision expert across this massive, noisy context space. It was computationally inefficient and just fundamentally unreliable.
So what Raymond outlines with synthetic parsing pipelines is a completely different architecture. Instead of one massive model reading everything, you have a routing agent. It looks at the document and breaks it down.
Right, it triage it.
Yeah. It identifies a block of text and routes it to a specialized language model fine-tuned for semantic extraction. Then it identifies a complex financial table, extracts the delimiter structure, and routes it to a data parsing agent that outputs clean JSON.
And it takes the diagrams and routes them to a vision model. The critical insight here is specialization. It is a swarm of domain-specific AI agents collaborating to process, clean, and structure the data before it is ever presented to the user or even to the main reasoning model. The agents are doing the prep work.
And we are seeing this move from enterprise backends directly into consumer tools right now. The Verge's coverage of Google Chrome's new AI skills is a perfect example of this.
Oh, absolutely. Those aren't just saved prompts.
No. They are essentially user-friendly agentic workflows. You are building a savable chain where the browser can autonomously execute a sequence of actions, like pulling data from a live web page, cross-referencing it with your Google Drive, drafting a response, and then staging it in your email.
Microsoft's Chief Product Officer for AI Experiences, Aparna Channapragada, contextualizes this beautifully in their 2026 trend report. She envisions this shift as AI moving from an isolated instrument to a deeply integrated collaborative partner.
What was the metric she used?
The metric she uses is that a 3-person human team can now conceptualize and launch a massive multi-regional global marketing campaign in a matter of days.
That is insane.
It is. The humans handled the strategy, the creative direction, and, the nuanced cultural taste. But the AI agents handle the localized translations, the programmatic ad buying, the A/B variant generation, and all the data parsing.
But, okay, I'm looking at the architecture for these agent swarms, and my immediate concern is compounding error rates and just, systemic fragility.
Right.
Because if I'm giving a swarm of agents access to my local files, my calendar, and my social media accounts, which is exactly what ByteByteGo highlights with persistent local agents like OpenClaw, how do we prevent a cascading disaster?
It's a very valid fear.
Right. If an orchestrator routes data to a vision agent, and that agent misinterprets a brand guideline and then feeds that back to the copywriter agent, I mean, you aren't just hallucinating anymore. You are laundering a hallucination through 3 layers of autonomous execution. If I'm not manually checking every step, how is my entire content calendar not getting nuked while I sleep?
That is the exact friction point that separated the theoretical AI of 2024 from the deployable AI of 2026. The solution isn't to force the human back into the micromanagement loop. That defeats the purpose. The solution is rigorous, systemic governance at the architectural level.
Okay.
This is where IBM Research's VP of Quantum and AI, Ismail Farrow, introduces the Agentic Operating System, or AOS.
So it's an operating system specifically designed to manage AI agents.
Exactly. Think of it like a kernel in a traditional computer, but for managing autonomous cognition. The AOS implements what Farrow calls the Objective Validation Protocol.
Objective validation. What does that actually look like in practice?
Well, when you set up a workflow, you aren't just defining the goal. You are defining rigid, programmatic validation checkpoints. So the agents are free to swarm, to debate, to generate variants, but they are strictly constrained by the AOS.
So it's essentially a policy engine.
Precisely. It enforces resource governance and safety compliance. Before an agent can execute a high-stakes action, like committing code to a live repository, transferring funds, or publishing a piece of media to 1 million followers, the AOS intercepts the action.
It catches it.
Yes. It evaluates it against the brand guidelines or the enterprise safety policy. And if it passes, the AOS triggers a mandatory human-in-the-loop checkpoint.
Ah, okay. This is the core of the Rick Rubin analogy again. You aren't playing the instruments, you are just listening to the track and saying yes or no.
Exactly. The agent has done 99% of the work. It has researched, drafted, formatted, and staged the post. You simply review the final output and click approve.
It reclaims human leadership in mission-critical environments without sacrificing the asynchronous speed of machine execution.
But for an agent to actually navigate a complex workflow, handle edge cases, and present you with a final product that doesn't require massive human editing, The underlying cognitive engine of the AI had to undergo a fundamental evolution.
Right. A persistent superagent is only as effective as the foundational model powering its reasoning.
Exactly. And the data from the Stanford HAI 2026 AI Index report shows that the capabilities of these models have violently accelerated.
Oh, the numbers in the Stanford report are genuinely staggering. I mean, we are looking at a landscape where industry adoption of Gen AI has hit 88%. This is no longer a peripheral experiment. It is core infrastructure.
And the economic value.
Yeah, the U.S. consumer value of generative AI has reached $172 billion annually. But honestly, the most compelling narrative in the Stanford data is the geopolitical shift in model capabilities.
The U.S.-China gap.
Yes. The performance gap, which was heavily skewed toward the U.S. for years, has effectively vanished.
The introduction of models like DeepSeek R1 from China was a watershed moment. I mean, in early 2025 and into 2026, we saw Chinese models not just matching, but in several highly complex reasoning benchmarks, temporarily beating the top-tier proprietary models from U.S. labs. They have been trading the absolute top spot back and forth for over a year now.
And the obvious question is how a relatively smaller lab closed that gap against companies spending tens of billions of dollars on compute clusters.
Right.
ByteByteGo provides a brilliant technical teardown of this, and it really comes down to a fundamental paradigm shift in how we train the models. It is the transition from RLHF to RLVR.
This is perhaps the most important technical concept for understanding why AI reasoning suddenly became so much cheaper and more capable. But to understand RLVR, we have to first understand the bottleneck of RLHF, which stands for reinforcement learning from human feedback.
Which was the secret sauce that made the original ChatGPT feel so magical back in 2022.
Exactly. In RLHF, you are essentially running a massive continuous focus group. The model generates two potential answers to a prompt, and a human evaluator reads both and clicks on the one that is, safer, more accurate, or more helpful. The model then updates its neural weights based on that human preference.
Which works incredibly well for aligning the tone of the model, right? Making it polite or teaching it how to format an email.
Yes. But the Stanford and MIT reports point out that RLHF hits a severe Pareto frontier when you move from subjective language tasks to objective high-level reasoning.
Right. Because if I ask a model to write a poem, a human can evaluate it in 10 seconds.
Yeah.
But if the model is generating 10,000 lines of highly optimized C++ code or attempting to solve a postgraduate level topology problem,
the human evaluator becomes a massive bottleneck.
Right. A human, even an expert, might need days to properly verify if that code compiles correctly, if it handles edge cases, and if it is memory efficient. You cannot scale a training run if your feedback loop is gated by the speed of human cognition.
The human labelers were slowing the entire evolution of the models to a crawl.
And that bottleneck is completely shattered by RLVR, which is reinforcement learning with verifiable rewards.
Yes. RLVR removes the biological bottleneck entirely. Instead of relying on a human to guess if a complex output is correct, the training architecture uses deterministic, verifiable environments.
Give me an example.
So if the model generates a block of code, the training system automatically runs it through a compiler. Did it compile? Yes or no. Did it pass the unit tests? Yes or no. If the model is solving a math problem, the system automatically checks the final balanced equation.
It is automated theorem proving applied to model training.
Exactly. And the implications for scale are just profound. Instead of waiting for a human to review one problem every hour, the model can now practice millions of complex logic puzzles per second.
Million.
Yes. It explores thousands of logical branches using techniques like Monte Carlo tree search, gets instant deterministic feedback on every single node, and bootstraps its own reasoning trace. It literally learns how to think by verifying its own work against absolute rules.
Which shifted the ceiling of AI intelligence from how many PhDs can we hire to label data to how many GPUs can we plug into the wall.
Exactly.
And the downstream effect of this training breakthrough is what ByteByteGo calls the DeepSeek moment. Because DeepSeek didn't just build a frontier-level reasoning model. They open-sourced the underlying architecture. They released the weights.
That was the earthquake. It proved that top-tier, verifiable reasoning was no longer monopolized behind the expensive APIs of massive closed-source labs. Open-weight models proliferated immediately after that.
Right, like Alibaba released Qwen 3 Coder next. These are models with staggering capabilities that developers can just download, modify, and run on local infrastructure.
This is a crucial point for the listener. The barrier to entry for having an absolute genius-level AI agent orchestrating your business has effectively dropped to zero. You don't need a massive enterprise contract to access this level of cognition anymore.
But, okay, before we crown these models as omniscient, I want to highlight a depthly counterintuitive and frankly hilarious metric from the Stanford report. They refer to the current state of AI capability as the jagged frontier.
It is a phenomenal descriptor of the cognitive architecture of large language models.
It really is. The report points out that a model like Google's Gemini DeepThink can solve mathematical proofs that would paralyze a university professor. Like, it can literally win a gold medal at the International Mathematical Olympiad.
Yeah.
But if you take the top AI models in the world right now and ask them to read an analog clock, they get it right only 50.1% of the time.
It is literally a coin flip.
It's wild.
And it perfectly illustrates that we are not dealing with human intelligence. We are dealing with an alien savant. A human learns sequentially. We build a foundation of spatial reasoning and common sense, and then we learn advanced calculus.
Right.
But an LLM learns by mapping high-dimensional probabilistic relationships across massive data sets. It can calculate orbital mechanics because the internet has vast structured data on orbital mechanics. But it lacks the embodied physical intuition to easily map the spatial relationship of two hands on a circle.
It's brilliant, but it is fundamentally brittle in areas we consider totally trivial.
Which is exactly why the architecture of how we use these models is changing. Because you can't have an agent that can solve physics equations but gets confused by a clock managing your entire workflow without safeguards.
Right.
ByteByteGo covers this shift toward adaptive reasoning, or what they call inference time compute scaling.
Right, like the thinking level parameter in the new Gemini models.
Exactly. Previously, an LLM used roughly the same amount of computational energy for every prompt. Whether you asked it to summarize a paragraph or write an operating system, it pushed the data through the same massive network of parameters. It was wildly inefficient.
So adaptive reasoning fixes that.
Yes. Adaptive reasoning allows the model to scale its cognitive effort to the complexity of the task. If you ask it a simple administrative question, it routes it through a smaller, faster subnetwork. It gives a cheap, instant answer.
But if you give it a complex coding task,
it activates its heavy reasoning protocols, it pauses, spends significant compute exploring multiple solution trees, verifies its own logic, and then outputs a highly refined answer.
It scales its energy expenditure, which drastically reduces the cost of running these agents at scale. And as these models become cheaper and smarter, the trend reports from IBM and Microsoft show that they are violently breaking out of the text box.
Moving into the physical world.
Exactly. We are moving into segment 3 of our analysis, beyond the screen. These agentic systems are now manipulating the physical and highly technical world in ways that feel like pure science fiction, but are actively deployed in 2026.
The most immediate and profound impact is definitely in healthcare. Microsoft's Dr. Dominic King details how AI has transitioned from a back-end research novelty to active, real-world symptom triage and diagnostics.
The data on Microsoft's AI Diagnostic Orchestrator, or MAI-DXO, is just staggering. They benchmarked this system against experienced human physicians on highly complex, multivariable medical cases. The human doctors had an accuracy rate of 20%.
Which is understandable for edge cases.
Right, but the MAI-DXO system achieved an accuracy rate of 85.5%.
An over four-fold improvement in diagnostic accuracy on the hardest possible cases. And it is vital to understand how the agentic workflow achieves this. It isn't just reading a list of symptoms. The orchestrator is performing multimodal fusion.
Meaning it's using all those different agents we talked about earlier.
Yes. It has a vision agent analyzing the raw pixel data of an fMRI scan. Simultaneously, a language agent is parsing the unstructured, handwritten notes from the patient's history. A data agent is cross-referencing their real-time blood work against millions of genomic sequences in global medical databases.
It is synthesizing a volume of diverse data in seconds that would take a human specialist weeks to review.
Exactly. And when you factor in the World Health Organization's projection of a global shortage of 11 million healthcare workers by 2030, this technology is not a luxury. It is the only mathematically viable way to close the global care gap.
Wow. And we are seeing a similar acceleration in pure science too, right?
Yeah.
Microsoft's Peter Lee notes that AI is no longer just analyzing data sets after an experiment is finished. It is becoming an active lab assistant.
Generating novel hypotheses.
Yes, designing the experimental parameters and actively controlling the physical robotics in the lab to execute the tests.
Which bridges us perfectly to the physical realm. ByteByteGo's report focuses heavily on the development of world models and physical AI. We are looking at systems like Google DeepMind's Genie 3 and NVIDIA's Cosmos Predict 2.5. These are fundamentally different from text predictors.
Yes, these models are designed to understand the physics of the real world. They ingest millions of hours of unannotated video data, and from that they deduce the laws of gravity, momentum, friction, and spatial reasoning.
But why are we teaching an AI physics? We aren't just trying to generate better video clips.
No, we are teaching them physics to solve the robotics bottleneck. If you want to deploy a humanoid robot like Tesla's Optimus or Boston Dynamics' Electric Atlas into an unstructured human environment, it needs a world model inside its brain.
It needs to understand cause and effect physically.
Exactly. It needs to be able to look at a room, simulate the physical consequences of its actions, and understand that a glass cup will shatter if dropped, while a plastic cup will bounce. We are training these cognitive engines in massive physics-accurate simulations so that the physical hardware can seamlessly navigate the real world.
But doing all of this, running the medical multimodal fusion, simulating real-world physics for millions of robots, orchestrating billions of super agents, it requires an amount of computational power that frankly breaks our current infrastructure.
The power wall.
Yes. IBM's Tautorial Magari points out that we are hitting the power wall. We cannot simply keep building larger data centers and feeding gigawatts of electricity into endless racks of standard GPUs.
The physical and thermal limits of silicon are becoming a hard barrier. So the focus in 2026 has violently shifted from scaling size to scaling fundamental efficiency. And this is where Jason Zander at Microsoft introduces the transition toward quantum advantage,
Right, specifically pointing to the development of the Majorana 1 chip.
which utilizes topological qubits. I want to pause here because this is incredibly dense physics, but it's the key to the next decade of computing. What exactly makes a topological qubit different from the quantum computers we've been hearing about for the last 5 years?
It solves the core problem of quantum computing, which is decoherence.
Right.
In a classical computer, a bit is a physical state. A transistor is either on or off. It is very stable. But in a quantum computer, a qubit exists in a state of superposition. It is incredibly powerful for calculating complex probabilities, but it is notoriously fragile.
Like you breathe on it and it breaks.
Essentially, yes, a slight fluctuation in temperature, a stray electromagnetic wave, or even a cosmic ray can cause the qubit to lose its state.
Yeah.
That is decoherence, and the calculation just collapses.
So previous quantum computers required massive energy-intensive error correction systems just to keep the qubits stable for fractions of a second.
Exactly. You needed thousands of physical qubits just to create one stable logical qubit. What Microsoft has achieved with the Majorana 1 chip is the commercialization of topological qubits. Instead of using trapped ions or superconducting loops that are vulnerable to local noise, topological qubits encode information in the braided paths of quasi-particles.
As non-abelian ennions, right?
Yes.
So the data is encoded in the topology, the physical shape of the paths they take, rather than their isolated energy states.
Yes. Because the information is stored globally in the braided structure, a local disturbance doesn't destroy the data. They are inherently physically immune to the noise that destroys standard qubits. They basically catch and correct their own errors at the subatomic level.
That is mind-blowing.
It is. This breakthrough paves the way for hybrid computing environments where stable quantum processors handle massive optimization problems like protein folding or material science, while traditional AI agents orchestrate the workflow.
Okay, I see the vision for the enterprise. Curing diseases, programming topological quantum computers, simulating physics for humanoid robots. It's amazing. But I want to pivot sharply here.
Okay.
How does this massive, multi-billion-dollar global infrastructure arms race actually impact you, the listener? If I am a solo creator sitting in my bedroom trying to build a business, how does a topological qubit or a data center in Virginia help me run a YouTube channel?
Well, because of the economic trickle-down effect of hardware efficiency, when the enterprise solves the efficiency problem at the top, the cost of compute plummets at the bottom.
Oh, that makes sense.
The sources point directly to the deployment of next-generation hardware platforms like the NVIDIA Vera Rubin NVL72.
Which provides up to a 5-fold improvement in inference performance over the previous generation.
And inference is the day-to-day cost of actually running the AI model. Training a model costs billions up front, but inference is the microtransaction of the model generating an answer or taking an action. When hardware efficiency causes inference costs to drop by 80%, running an always-on swarm of AI agents stops being an enterprise luxury and becomes a consumer utility. The drop in inference costs is the exact economic catalyst that allows a single person to run a digital media empire from their laptop.
Which brings us perfectly to our case study. We're going to look at exactly how a solo creator is leveraging plummeting inference costs, open-weight reasoning models, and agentic orchestration to build a faceless media brand right now.
This is based on the source material provided regarding the Baddie blueprint.
Yes, it is a masterclass in applying enterprise-grade automation to the creator economy. The Baddie Blueprint operates a highly successful YouTube channel called AI Baddie's Promo, and the brand's aesthetic is built around the intersection of beauty, coding, and automated confidence.
But the defining feature is the host, Nova.
Exactly. Nova is entirely AI-generated. The creator behind this brand never turns on a ring light. They never sit in front of a camera. They are purely the architect of the system.
And if we break down their tool stack, it perfectly mirrors the synthetic parsing pipelines and agentic workflows we discussed earlier. They aren't just using one app, they have built an automated supply chain.
What are they using?
Well, they utilize Midjourney and RenderNet to maintain absolute visual consistency for Nova's appearance across thousands of frames. They use 11 labs to synthesize a highly emotive, consistent voice model. They utilize ChatGPT, likely acting as the central AOS or orchestrator, to ingest trending topics, analyze SEO, and output structured creative briefs. And they integrate Sora for high-fidelity video generation.
The monetization strategy is equally diversified and programmatic. They are routing traffic and converting across FanView, Amazon storefronts, and Ko-Fi. But what I find fascinating is the creators' acute awareness of the macroeconomic hardware trends we just covered.
Right, in their community posts.
Yeah, they are actively tracking the deployment of 400,000 H200 chips into the market and discussing the Vera Rubin architecture.
Because they understand that they are running a tech startup, not just a vlog. They know that a flood of advanced silicon into the server market means lower API costs for their agent swarm, which of course increases their profit margin per piece of content.
And we can map their operational strategy directly to Microsoft's concept of repository intelligence, which was detailed by Mario Rodriguez in the context of GitHub.
That's a great connection.
Right. Rodriguez explains how AI can now understand the entire historical context of a code base to automatically generate complex patches and maintain architectural consistency. Well, this faceless brand is doing the exact same thing, but for media.
The repository isn't code, it is the brand guideline.
Exactly. The human creator establishes a repository of data. The specific hex codes for the brand's aesthetic, the pacing of the edits, the exact tone of Nova's voice, the historical performance data of which Ooks retained viewers the longest on TikTok versus YouTube Shorts.
So the agentic system acts as the repository intelligence.
Yes. So when the human says, create a campaign for the new Medicube Jelly Brush for our Amazon Finds playlist, the orchestration layer takes over. The script agent queries the repository for the highest performing hook structure. The visual agent generates Nova holding the product with perfect lighting consistency. The voice agent synthesizes the audio. The editing agent compiles it. They generate 10 different A/B variants.
And then the human executes the objective validation protocol.
Boom.
They review the variants, select the winner, and the distribution agent handles the cross-platform staging. It is a cyberpunk-style workflow brought to life, completely devoid of gimmickry. You are separating the creative design thinking from the raw manual production.
This is the ultimate leverage for you, the listener. You do not need to commoditize your own face or burn yourself out on camera to build a media company in 2026. You design the AI Plus Creator Brief workflow, and your AI interns execute it tirelessly.
It's a massive shift.
But relying on this infrastructure introduces entirely new attack vectors. Handing the keys of your brand or your enterprise over to autonomous agents creates massive vulnerabilities. This brings us to the final major theme of our sources: security, sovereignty, and the double agent risk. Because if your entire livelihood relies on these systems, you need to understand how they break.
And the security paradigm has completely shifted. Vasu Jekyll, Microsoft's corporate vice president of security, issues a severe warning about the unique threat of agentic workflows. She introduces the concept of the AI double agent.
How does an AI intern become a double agent?
It primarily occurs through sophisticated prompt injection attacks or poisoned data streams.
Like embedded in the data they are parsing.
Exactly. Remember, these persistent agents have access to your most sensitive environments, your email, your local files, your financial APIs. If an agent is tasked with summarizing an external web page or reading an incoming email, a malicious actor can embed hidden text in that data.
Rendered invisible to the human eye but readable by the LLM.
Yes. That hidden text contains a prompt injection that essentially overrides the agent's core directives.
It literally hijacks the agent's cognitive engine.
Yes. The agent reads the invisible text, accepts it as a new high-priority command, and suddenly your trusted internal agent is quietly exfiltrating your customer data to an external server, or inserting malicious links into your automated social media posts. The threat bypasses your traditional firewalls because the agent already has authenticated access to the inside of your network.
Wow. Which makes the data from Offmine's CEO, Shlomi Yanai, incredibly alarming. He warns that we are crossing a threshold where non-human identities, meaning these autonomous AI agents, will vastly outnumber human users within organizations.
It is a structural nightmare for traditional cybersecurity. For decades, identity and access management meant verifying biological humans. Did the employee use their biometric scan? Did they use two-factor authentication? But how do you secure a network when you have 5,000 human employees and 50,000 autonomous agents continuously pinging APIs, accessing databases, and executing code? You have to transition to zero-trust architectures specifically designed to monitor machine-to-machine behavior for subtle anomalies.
And the vulnerabilities aren't just in the software layer. The Stanford AI Index report highlights a geopolitical hardware vulnerability that affects everyone from the Pentagon down to the solo creator running the Baddie blueprint.
It is arguably the single greatest point of failure in the modern global economy.
The Stanford data shows that the United States is the undisputed heavyweight in AI infrastructure. The U.S. hosts over 5,400 massive data centers. That is more than 10 times the infrastructure of any other nation on Earth.
But the critical caveat is the physical supply chain that builds the silicon inside those data centers. The entire global AI engine, virtually every high-end GPU required to run these models, is heavily dependent on a single physical choke point, the TSMC foundries in Taiwan.
One company, on one island, manufactures the physical bedrock of the 2026 economy.
Yeah. If there is a massive earthquake, a prolonged power grid failure, or a geopolitical conflict that disrupts the supply chain in Taiwan, the global rollout of AI agents doesn't just slow down, it hits a brick wall.
This is exactly why the concept of AI sovereignty has moved from academic debate to defining national policy. Anthony Marshall at IBM details how nations and massive enterprises are realizing they cannot outsource their core cognitive infrastructure.
You cannot run a sovereign government or a Fortune 500 company if your fundamental reasoning engines rely on foreign compute or closed-source models that can be geo-blocked overnight.
So Marshall argues for immediate implementation of modular architecture.
Yes, the ability to seamlessly shift workloads. If a data center in one region goes down or an API is restricted, your agentic operating system must be able to automatically reroute its tasks to a trusted, localized, open-weight model running on sovereign hardware without breaking the workflow.
And this macroeconomic concept trickles all the way down to our solo creator. If you look at the episode list for the Baddie Blueprint podcast, there is an episode titled TikTok and X Crashed. Did your business survive?
That is the micro application of AI sovereignty right there.
Exactly. If your entire Faceless brand relies on OpenAI's API and OpenAI goes down, you are out of business for the day. If your distribution relies entirely on the TikTok algorithm and that platform is banned or altered, your agent swarm is yelling into the void. You must own your repository, your localized models, and your audience data.
You have to build resilient sovereign systems, whether you are running a country or a YouTube channel.
Which leads me to two strong conclusions based on the massive amount of data we've synthesized today. Hot take number one. By 2026, the most powerful and profitable creators won't be the ones with the loudest personalities or the best lighting. They will be the ones with the tightest AI-driven systems architectures. Pure charisma is being commoditized by AI avatars. System design and prompt orchestration are the new premium skills.
I completely agree. The leverage has definitively shifted from the performer to the architect. And hot take number two.
Hot take number two. If you are still using AI like a glorified search engine, typing a prompt and waiting for an answer, you are only utilizing 10% of its power. You are using a supercomputer as a pocket calculator. The real exponential leverage is in persistent AI agents, verifiable reasoning models, and fully automated workflow skills.
To synthesize our entire journey today, we have definitively crossed the threshold. We have moved from the era of single-prompt chatbots to the era of sophisticated, RLVR-trained super agents. We have models capable of multimodal fusion that can outdiagnose human doctors, simulate physical reality for humanoid robots, and act as a tireless 24/7 faceless media team.
The economic barrier to entry has essentially vanished due to plummeting inference costs.
Right. The new barrier to entry is your ability to design the orchestration, implement rigorous validation protocols, and secure your systems against novel threat vectors.
The linear math of traditional business, the idea that you are the bottleneck to your own output, is broken. You are the conductor now. So I want to speak directly to you, the listener, with a specific next step.
The CTA.
Yeah. If you want to go deeper into exactly how these platform shifts, automation protocols, and agentic workflows are being used to build highly profitable, faceless brands right now, you need to look at the practical applications. Check out the Baddie Blueprint blog for detailed breakdowns that turn these massive enterprise trends into step-by-step workflows you can implement today. And subscribe to the Baddie Blueprint podcast wherever you listen to audio.
But before we sign off, I want to leave you with a lingering thought to mull over. Something that builds on the societal data we briefly touched on from Stanford. Their research shows a massive 50-point trust gap regarding AI.
Right.
73% of industry experts believe AI will positively impact jobs and society, but only 23% of the general public agrees.
That is a profound disconnect between the architects and the users.
Exactly, and it raises a fascinating, somewhat existential question about the trajectory of media. As we move into a world where faceless brands like the Baddie Blueprint win the algorithm by using swarms of AI agents to flawlessly generate, optimize, and post content, how long will it be before the consumers of that content are also AI agents?
Oh, wow.
Right? If your AI interns are generating optimized video scripts just to have the viewer's personal AI assistant ingest, summarize, and filter that content for them, what exactly is the human's role in the internet of 2030?
Are we just the biological bootloaders who launched a digital conversation that we aren't even a part of anymore? We want to thank you for joining us on this deep dive. Now go build your system.